Okay, hi everyone. So this video is about comparing two temperature and humidity sensors, DHT11 and DHT22. This is just an unusual forward I want to give you for this video because for various reasons, various events and a lot of disasters happening, this video took almost 1.5 months to create with numerous re-recording and losing data and doing stuff from all over from scratch and so on. As you will see, audio quality will be a bit different during various parts of the video. This is just because it was too late for me to realize that NVIDIA's Shadow Play I was using to record my desktop is doing a total messy job with microphone recording. I mean, this is right now recorded by Audacity, and even if I'm using the same mic, the recording quality of Shadow Play, it's not even in the same league that of Audacity's. So sorry for the audio issues, and I don't want to waste any more of your time. Enjoy the rest of the video. Hey everyone, this is Maniac aka the Tinker here, and today we are having fun with temperature and humidity sensors. So on this board you can see I already wired up two of these sensors, namely the DHT11 and the DHT22. These models are both temperature and humidity sensors, so 2 in 1, and I added them to a Node MCU so I can read measurements, and as a control group I will use baby room temperature and humidity sensors. So those viewers who had or have a baby know that these things are pretty accurate, and because of that I thought it will be enough to be used as a control group. So this is just a simple Arduino project consisting of a single file. It uses the DHT library, which is like a common interface for both of these modules. So both for the DHT11 and for the DHT22. Using it is quite simple. So this code could be like half of this long, but I added some NTP voodoo magic to have time stamp written into the log files, or to be precise, the time in human readable format written into the log written to the terminal output. But there's just some extra fancy stuff, has nothing to do with the DHT related code itself. Also, anything that is related to Wi-Fi in the code is belongs to that NTP code to get the time from an NTP server. But obviously using the sensors does not require a Wi-Fi connection. Okay, so back to the library itself. Usage is quite simple, as I said. You just define a DHT object, provide the pin number and the sensor type. So it's either DHT11 or DHT22. In this code I measure values from both sensors at the same time. So I've instantiated 2 objects, and as pretty much with any Arduino or ESP code, you have to initialize the objects, then in the main loop you can actually use them. In this case we have 2 methods for querying values. One is for reading humidity and one is for reading temperature value. So these methods return floats regardless of the sensor type we are using, but as you can see on the terminal monitor, DHT11 itself returns integers, while the DHT22 returns real floats with fraction of a percentage. Okay, so as I said, the code is quite simple. I read these values and log them along with the timestamp and some fancy messages, but basically that's it. I will obviously put this code to GitHub for whoever wants to download it or check it out. Not just in a video, but in an editor or something like that. It's free to use, so use it if you want. Okay, so that's it about the code. Now I want to talk a bit about the sensors themselves. So we have a page on the Adafruit library that explains some info or shows some info about these sensors. So to be more precise, this is a comparison. And what we are talking about is basically two cheap sensors. Even there's something like I think, yeah, the DHT22 costs like 3 or 4 times as much as the DHT11. So considering the price difference, the price gap is actually huge, but not that huge. I mean, we're still talking about a few bucks here. Okay, so we're comparing an ultra low cost and low cost sensor. They both have similar parameters like voltage, current use, and so on. What is the main difference basically is the range they are returning values in and the accuracy. So you can see that for the DHT11, basically you can use it anywhere where you can ensure that the temperature does not go below 0 Celsius degree, while the DHT22 is usable even in a real cold winter down to minus 40 Celsius degree. Same goes for humidity. Basically, DHT22 covers the whole humidity range, starting from 0 up to 100% humidity, while DHT11 is just a part of it, starting from 20 and up to 80% humidity. Also, the accuracy is different. In general, you could say that the DHT22 is more accurate. On the other hand, it is pretty much 2 times as slow as the DHT11. So while you can sample the DHT11 in every second, you can do that for the DHT22 in every 2 seconds. So I guess this is the cost of the accuracy. Other than that, pretty much similar parameters. Okay, let's have some experiment here. So I've set up the sensors like a couple of hours ago, and they have been running since then, reporting data here. And basically, they are just showing steady values for now. Even if you notice that the values are somewhat different, I think this can be counted for the accuracy difference mentioned on the Adafruit page. So as I mentioned, I want to do an experiment. So outside at the moment is a cold and rainy weather. So as soon as I open up the windows, hopefully the temperature will go down and humidity will go up. And I want to measure how fast these sensors are reacting to this change, and obviously how the device I use as a control group will react to that change. So I will just open the window now. You can see the timestamp, and I will stop recording. I will resume recording like 10 minutes later or so, and we will see what happened within 10 minutes. We can just scroll back in this log and see the timestamp and see how fast the sensors reacted. Okay, so welcome back. Yes, I can say welcome because actually it's not like 15 or 20 minutes or something like that has passed, but since the previous part of this video, but actually hours. And to be honest, as the title says, this review is cursed. There was a thunderstorm, I lost all my temperature data, had to work on changing the temperatures, I mean the room temperature again, and so on. So I ended up with a total mess, and I decided not to wait again like for hours to the room to get back to its normal temperature, normal humidity, start the whole measurement again, and so on. So instead I did the following. Instead of using the serial monitor, I'm using Elasticsearch now. This is, to put it really simple, it's a database that you can pump a lot of data into, and using another tool called Kibana, you can do nice diagrams and so on, like you can see on the screen now. And this Elasticsearch installation is sitting on a server of mine, which is behind a UPS, an uninterruptible power supply. So I know that even if another power outage happens due to thunderstorm, I won't lose data again. So I strapped that whole breadboard with the two sensors onto a power bank to make it also independent from the mains power, and do the measurement in the room again. Then to speed up things, because as you can see on the timestamps, it's really late in the night. To speed up things, I just put the whole thing outside, where currently it's like 9 degrees Celsius or something like that. So anyway, now we have some real results, and as a preliminary, I can say that I'm not really convinced by the DHT22. So what you can see here is starting from an indoor environment, going to an outdoor environment to a much lower temperature and somewhat higher humidity, then back to an indoor environment. And as you can see, the transition is pretty much the same for both sensors, except obviously it's smoother for the DHT22 because of the higher precision. So this is basically the point where I just I had the device in my hand. So obviously it's an instant temperature jump, and this is the point where I put it outside to the balcony, and suddenly temperature started dropping. And using these diagrams on Kibana, we can just compare the two. So for example, 5 minutes after 1 a.m. it says 12 degrees, while the other one at the same time says almost 14 degrees. So the whole point is that the transitions happened pretty similarly. Also, there are some interesting facts regarding humidity. I will get back to that later. But all out during the whole experiment, that 1.5 Celsius degree difference between DHT11 and the DHT22, that remained constant. And even at the lowest point, which was 8.7 Celsius degree for the DHT22, and it was 7 for the DHT11. So in general, we can say that the DHT11 always reports somewhat lower temperatures, 1.5 degrees lower than the big brother. So here it's 10, and at the same time, where is it? It's 11.5. So you can see a pattern here, and for me this does not justify the price of the DHT22, because if there's a constant difference between the two, I can just use the DHT11 and offset my equipment, like basically adding 1 Celsius, or to be honest, not even a single Celsius, because as I said, that room measurement device, that baby monitor device I used as a control group, is sitting between the two halfway, and unfortunately couldn't use that to put values into Kibana and have a third diagram here, because it doesn't work like that. It's a self-contained device without Wi-Fi connection or whatever. It's just a simple device displaying the actual data. But I kept checking it and obviously moved it outside along with these 2 sensors, and that device showing a number between the 2 values of the 2 sensors also remained constant. So we are not really dealing with anything special here, besides the fact that there's a difference. Okay, what else? Yeah, I guess that's it about temperature. So they reacted to the temperature change similarly, like maybe the DHT22 was a bit slower to react, but I'm not that convinced that it's not substantial. So I just leave it like that. The main point is that after they were brought back into the indoor environment, everything started to go back its original state, like having a difference again as usual, and so on. So as I said, given the price tag difference between the 2 sensors, even if especially if I use them in large numbers, because let's face it, neither of them are expensive, but small costs can add up, and if you have to use for whatever reason 1,000 DHT11s, then the price tag will be the price gap will be much higher. Okay, so as I said, that's about the temperature difference. Now regarding humidity, somewhat similar, but there are some interesting points to mention here. So first of all, documentation says that the DHT11 can report up to 80%. As you can see, it reported actually much higher than that. So I guess it's the Adafruit documentation that is inaccurate at this point. Unfortunately, I don't have something like a desert at hand to test how does it work in an extremely dry environment. If you have any ideas how to test that, just leave it in the comments. I would be grateful for that, because maybe a biologist or someone else could say how to test extreme humidity conditions, but let's face it, I'm just a software developer, so that's not really my area of expertise. So I live with what I have. Okay, so point is that the DHT11 reported these values. Interestingly enough, both of them had this bump, because I guess this is because when I brought the device back into the indoor environment, there was like a sudden temperature change affecting Okay, another thing to mention is that there's a huge difference between reported values. Like DHT11 reported something almost 70, and this was the time the device or this whole circuit spent outside. And at this point, just the DHT11 just reported 88 constantly. So it's quite interesting. I'm not sure. It is possible also that the Adafruit documentation is indeed right, and this whole thing about 80 is just a bogus, I don't know, some estimated data or something like that, because this was really interesting. Okay, anyway, point is that here you can see again similar reaction times, like 54 here, 51 and 51.4 here, and you can see 1 minute later there's a jump, 1 minute later there's a jump. This is 8%, this is nearly the same amount, a bit less. Then this is also a jump because I took the circuit into my hands, and obviously the human body has different humidity, and this is when I put it outside. So it's a sudden jump. Just we are after a rainfall, and the weather outside is quite moist. But while in case of the DHT11, there's a huge jump in like a matter of 3 minutes. Similar jump took, I don't know, to reach the top, more than 10 minutes for the DHT22. So I can say I'm not really sure about these humidity measurements. This straight cap of 88 sounds strange, and also this very slow reaction time from the DHT22 sounds strange as well. Also this high peak, it shouldn't be that high. I mean, okay, I grabbed the device from the balcony, I had it in my hand, but Jesus Christ, is like a 30% increase in a minute. I don't know. I wasn't sweating or something like that. So this is pretty inaccurate. This is just bogus data here. Okay, so I guess that's it. To have this, I had to modify the code. I will also upload that to GitHub. Basically, let me show you. So I just added another library called PopSub Client, which is my de facto standard for publishing stuff to MQTT. And since I have an MQTT broker set up on a Raspberry Pi in my house that I use for Sonos and other stuff, I just pump the messages in every 10 seconds into that broker, and there's another piece of software I'm working on that grabs messages like that. Basically it just listens for temperatures and other sensors data and pumps those into Elasticsearch. Before you ask that, yes, this is a two-step process, and yeah, ESPs could just directly put their data into Elasticsearch, but since I have a mobile application called MQTT which is also responsible for picking up MQTT messages. This two-step process is necessary. I mean, by MQTT I can just notify a lot of different devices and tools, while putting the data directly to Elasticsearch would strip me of that possibility. Okay, so I guess I'm going to have a nice sleep now and edit this video. Yeah, this one with all the bad luck and the illness and whatnot I had. This one took 1.5 months to create and to record and to re-record and to re-record, and Jesus Christ. Okay, anyway, thanks for watching this, guys. If you like this video, hit subscribe, hit like. As a beginner YouTuber, that helps me a lot. So thanks for your attention, and see you next time.